Welcome. Today's topic is all about computer logic gates. I want to show you where you can download the document we're going to be using today. It's out on the calendar. If you click on the calendar entry and say more details, it'll take you to a page that looks kind of like this. And what you want to do is download this document. So you click on it. Here's a symbol for downloading, so you download that. What it will do is it will put it down here. Once it's down there, you want to go and find it in the folder. So you just click on this part here and say Show in Folder. It shows me where I've downloaded it to. And I want to copy that. And I want to put it in my H drive. For me, that's my Z drive. But for example, if this were my H drive, I'd put it in my little computer hardware folder and paste it right there. Then when you're done with it, you can drag it into your 2 grade folders. During the lecture today, I'm going to go over how to fill out this form. So you might as well have it up and ready to go as you're watching this video. Alright, it's going to look a little bit weird unless you click on it and say Enable Editing. And then it will look somewhat normal. So that's our worksheet for today. I'm going to walk you through the process of how to fill this out. Today we're learning a little bit more about logic gates. You have to recognize when we're talking about computer logic gates is that there's lots of different ways you can represent what we're talking about today. You can use pictures like this or like this over here. These are schematics. This is called a Venn diagram. I also list what the name of the gate is, and then there's something called Boolean algebra. And what does this gate look like when written in Boolean algebra? Also, we'll be filling out these truth tables as we go through the lecture. So again, I would suggest having this open and getting ready to insert some material into this document. Well, let's look at the first one here. This is called an AND gate. If you look on the left side of the gate, those are the inputs into the gate. In this case, we have an input labeled A and B, and then an output labeled Y. Now the shape of the schematic tells you what kind of gate it is. The way you can tell an AND gate from the other types of gates is that it looks like the letter D, or more like a bullet. The side of it is important. This flat side, that kind of gives it away, is that it's a type of AND gate. So an AND gate looks like this. The gate's name is AND. The symbol looks like multiplication symbol. It's a dot. But it is a multiplication, and the way you would read that in English, you would say A and B equals Y. Now, the one similarity it does have with multiplication is you can leave the dot out if you want. So these two equations are equivalent. Again, that reads a little bit differently. It reads A and B. Same thing here, A and B equals Y. Now here's something called a truth table. Now, truth tables and Boolean algebra all were kind of created back in the 1800s. It seems kind of odd since we're talking about computers, but a lot of this logic theory came from a mathematician called George Boole. And what he was trying to do is trying to prove mathematically certain statements as being either true or false, and using that to come up with like a mathematical proofs for English statements. And so I want to give you an example of that. All right, let's say I have 2 statements. If I say the earth is round, so let's call that statement A. The earth is round. And statement B, which is the sky is blue. 2 statements. You can read these statements as either being true or false. And we're going to use these statements to help us kind of understand what's going on in an AND gate. Let's go back to our documents here. What we're saying is statement A, the earth is round, that's true. And statement B, the sky is blue, that's also true. So if we say the earth is round and the sky is blue, taken together, that would be evaluated to true. So that's what y is the, after we evaluate the two statements, whether or not it's true or false. So in the case where both statements are true, the result is also true. Let's change one of the statements now. The earth, or the sky, is purple, let's say. Say those are our two statements. Going back to our document then. Well, the first statement is true. The earth is round, but the sky is not purple. So if you would say, the earth is round and the sky is purple, taken together, that statement would come out as false, right? Because the sky is not purple. So when you say the word and, that kind of means both of them have to be true. In this case, one of them isn't. Let's take a look at the other one then. Like say the earth is flat and the sky is blue. So statement B is true, but statement A is not. What does that look like in the truth table? Okay, well, the earth is not flat, but the sky is blue. So the earth is flat and the sky is blue. Taken together, no, that's still not true. Okay. Going back to our conditions here. This time we're going to make them both false. Okay, the earth is flat and the sky is red. Both of those are false. So if I were to say the earth is flat and the sky is red, well, neither one of those statements is true, so you'd still get false coming out. So the only way you can get true to come out of an AND gate is if both inputs or both conditions are true. So what I'd like you to write down in your notes is for and both inputs must be true for the output to be true. Okay? For and, both inputs must be true for the output to be true. Otherwise it's false. And that's what you would say in English. If someone asks you, well, what does an AND gate do? You would tell them this. All right, let's look at the next gate then. Next gate is the OR gate. And you'll note on these gates that their shape kind of gives you away what they are. This one kind of looks like a shield to me on its side. The thing that really makes it obvious is this kind of concave section here at the front. If you see that, that's some kind of OR gate. There's different flavors, and we'll talk about those shortly, but these are the ones that I'm looking at. So the symbol for that is a shield. The schematics is a shield, but the symbol is a plus sign. Now we don't say plus. Again, this is Boolean algebra, so we say A or B equals Y. So you read that A or B. And we're going to do the same thing with that. Taking a look at the truth table. A or B, what happens with Y when we do that? We'll go back to our example. The earth is round and the sky is blue. So both statements are true this time. But instead of and, we're going to say or instead. So if I were to say the earth is round or the sky is blue, well, actually both of them are true, so we'll say that's true. Let's take a look at the next one then. When the first one is true and the second one is false. So the earth is round or the sky is green. Is that true or false? Well, the earth is round, the sky's not green, but you said or. So I guess the earth is round or the sky is green. Well, yeah, one of them's true, so we'll say that's true. Notice that differs from what we have up here. Next one, let's look at the statements. The earth is flat and the sky is blue. How does that affect our truth table? Well, right here we would say the earth is flat or the sky is blue. Well, the sky is blue, but the earth's not flat. But I said or, so that must mean then that's true, because one of them's true. finally, we have it where both statements are false. So, say the sky is yellow. Well, we know that the Earth is not flat and the sky is not yellow. Both of those are false, so the Earth is flat or the sky is yellow. Neither one of those are true, so that's going to evaluate to false. So how would I summarize an OR gate using English, or an English description of it? I would say this. I would say OR. Just copy this with one slight change. Both inputs must be false for the output to be false. Otherwise, it's true. Maybe add that little otherwise part. Same here, I would say. Otherwise, it is true. Let's look at the next gate. It's called a NOT gate. And what you notice on it is there isn't two inputs. There's only one input. So one input and one output. It's called NOT. The way you describe NOT is you put a line over whatever you're negating. So here's A. If I want to say not A, I put a line over the top of that. So you would read this in English, not A equals Y. If we say the Earth is round, that's true. Now if we not that, we get the Earth is not round. Well, we know that's false, so we'll put false here into our truth table. Now let's take a look at a false statement. Again, we'll go back to the Earth is flat. We know that that's not true. So here in our document then, we would say the Earth is not flat. Okay, so the statement we have is the Earth is flat. If we negate it, we'd say the Earth is not flat. And it isn't, so that would be true. So true becomes false and false becomes true. And so that's how I try to remember it. So for the NOT gate, true becomes false, false, and false becomes true. Kind of like politics. Bad joke. All right, going back. Now, I haven't talked too much about these diagrams off to the right. If you've taken any classes where they talk about set theory, kind of a math class, there's a type of diagram that's called a Venn diagram. If you're used to those, you can see kind of a picture of what the truth table is trying to tell you. The only way you get true, so you see the shaded area as the true part. The only way you get true is if both A and B are true. So that's kind of what it looks like there. When you say A or B, notice there's a lot more that can be true. It could be just A or B or both. Any of those is fine for it to be true. Here it's just the opposite. If A is false, then the true part is on the outside. Let's look at the next one, called a Nand Gate. And it looks a lot like an AND gate, so you have to really pay attention here. You look here at the schematic, and the only thing that differentiates it is this little circle right here. Anytime you see a circle in a schematic, that tells you it means not. That would be the equivalent as taking an AND gate, and at the end of the AND gate, putting a not right after it. So not and. That's the way we should fill this out, is a NAND gate is not an AND gate. How's that written in Boolean algebra? Well, it's kind of weird. The AND operator is still there, but then you have this line over the top. Remember, the line over the top means not. So if you're going to write this schematic in Boolean algebra, you'd say A and B, and then draw the not line across the entire equation, because you're negating the whole equation. What you're really saying here is, I need to get the opposite of A and B. Luckily up here we've already done and, right? So if it says not and, that means it would just be the opposite of whatever we have here. Now on the second half of this worksheet, I'm kind of transitioning from trues and falses. Instead of true now, since we're talking about computers, true is going to be represented by the number 1. False would be represented by the number 0. So let's try that in this truth table. First of all, we take a look at the AND gate, and we see that we have true, false, false, false. So looking down here, that would be 1, 0, 0, 0. But remember, this is not an AND gate, so it'd be just the opposite. So we're going to say 0, 1, 1, 1. So the pattern you see on the truth table then is the exact opposite of what you see in the AND gate. True, false, false, false becomes false, true, true, true. Here's the next one. It's called a NOR gate. NOR meaning not or. Again, it looks a lot like an OR gate, so you got to pay attention. Got the little circle there. That's what makes it a NOR gate. The syntax for Boolean algebra is a little bit strange. It's a line over a plus sign. So you would say A NOR B equals Y. And again, we just look at our OR gate and we say, well, what's the opposite of this? True, 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 false. We're going to make it false. Well, true, 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 false would be false, 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 true. Okay, it's just the opposite of an OR gate. So those are pretty straightforward, those 5 gates. There's a couple others that we need to mention just to be complete. We use this one in later work on this unit. This one is called an exclusive OR gate. Now what does exclusive OR mean? Exclusive OR? Sometimes it's written like this, XOR. So what's the equivalent English phrase for that? You say one or the other, but not both. That's how I remember it. One or the other, but not both. So one can be true or the other can be true, but both of them can't be true for you to get true out of it. One or the other, but not both. Well, here both are true. So if we follow what we said, one or the other, but not both, this would be false. You can't have them both true. So it's different than and. One or the other, yeah, we got this one. Here's the other one. So these are actually be true in here in the middle. But still, if both of them are false, we're still going to get false from a exclusive OR gate. So you either have one or the other, but you can't have both, or you can't have neither. And the last one's kind of a funny one, called XNOR. Basically, it's a NOR gate, or it's an exclusive OR gate that's been negated. So again, you see the little circle there. What's the symbol for that? I forgot to mention up here, exclusive OR is just an OR with a circle around it. An XNOR operator is a circle with a plus sign, or a plus sign with a circle around it, and a line over the on top of the whole equation. The way you state this is it's the opposite of exclusive OR, so it would be 1, 0, 0, 1. So again, we have and, or, not, exclusive OR. And then we have negations of and, the Nand Gate, the NOR gate, and the XNOR gate. That's a pretty good description of all the logic gates we're going to see in the class as we learn how computers do what they do. What I'd like you to do is save this, and then once you're done filling this out, no need to put your name on it because you're going to download it from your H drive into your 2 grade folder.